Okay, which one do you need help with? 18? Yeah, they have it. Okay, yeah, this is a good one. This is fun because we get to make a tree diagram here. And the tree diagram is super, super helpful for solving this problem. So it says a football team has a 70% chance of winning when it doesn't snow, but only a 40% chance of winning when it snows. Suppose there's a 50% chance of snow. So my first two branches are going to be snow and no snow. And what are the probabilities of each one happening? 50%. So this is 0.5 right here, and then this is 0.5 right here. Then, off of each one of those branches, what is the next branch? But what are the labels? Right, winning or losing. So I can go win right here or lose right here. And then if it doesn't snow, we still have two different things that could happen. I could win or I could lose. All right, so give me some percentages that go with those. Colin?
On no snow, win 70.
Okay, it says if it doesn't snow, they have a 70% chance of winning. So that's a 0.7 right there, which means that if it doesn't snow, what's their chance of losing? 0.3. Awesome. Okay, and then they have a 40% chance of winning when it snows. So that's 0.4 here and 0.6 there. Okay, so then we have four different possible outcomes. It could snow and we could win. It could snow or we could lose. It could not snow and we can win, or it could not snow and we can lose. And the way that you figure out the percentages for each one is you just multiply them. Yeah. So 0.5 times 0.4 is 0.2. 0.5 times 0.6 is 0.3. 0.5 times 0.7 is 0.35. And 0.5 times 0.3 is 0.15. And notice that those will always add up to 100% if you do it correctly. Colin?
And then you add 0.2 with 0.35.
Good, because what we're interested in, what are the chances that we can win? And winning right here is a 0.2 chance. Winning right here is a 0.35 chance. So if I add those together, then overall I have a 55% chance of winning. Okay? Okay, other questions? Other questions? That's it?
Yep.
Okay. Awesome. Will you pass those forward, please?
30.
Oh, 30?
Yeah.
Okay. Okay, 30. The tree diagram, again, relates snowfall, this time with school closings. Find each probability. Let H, L, O, and C represent heavy snowfall, light snowfall, schools open, and schools closed. So I'm going to, thank you, I'm going to multiply these together, finish the job for them here. 0.4 times 0.8 is 0.32. 0.4 times 0.2 is 0.08. 0.6 and 0.3 make 0.18. And 0.6 and 0.7 make 0.42. Okay, so this number 30 says, what is the probability of having light snowfall given that school is closed? So which ones of these represent school being closed?
0.32
The 0.32 and the 0.18. So there's a 50% chance that school will be closed. Out of those 50% chances, which ones of those involve light snowfall?
0.18.
The 0.18. So it's going to be 0.18 out of 50, which is 36%. For 30? Did I do that wrong?
Yeah.
What did I do wrong?
You listen to me by the 0.18 probably. I think you need to add 0.18 and 0.42 together.
I did the point, so the school closing, like I said, that's this outcome right here, and this outcome right here involves school closing. So overall, there's a 50% chance of that happening, right? It's what? No, because this is heavy snowfall and school is open. Should I look up the answer and see? Jennifer has my teacher's book over there. Jennifer will look it up for us in a minute. So you did, how did you do it? You did what? You just did 0.18?
Where does it
Oh.
tell you that it's closed?
C stands for closed. So we're looking at number 30, Jen?
Well, what's 0.18 divided
On the
by
bottom underneath it has the answers. 0.36. So yeah, so it's the probability that school will be closed, and then the probability that when that happens you'll have light snowfall. Okay? So you might, well no, that's an and. Okay, anything else? No? Okay, will you pass those forward? In 6th period class, just hang on to yours and I'll collect them tomorrow. Okay, so we're going to just go through these problems together. You guys can copy them down as we go. And then we have a quiz tomorrow, and you may use these notes on the quiz if you would like, okay? All right, so going way back, the first thing that we started to talk about in this chapter is different ways to count the number of ways that things can happen. And in the process of those conversations, the exclamation point notation came up. What does that mean?
4, 3, 2, 1.
Right, that stands for, what's the word that stands for?
Yes.
Factorial. Good, so this is saying 4 factorial. And to do that, you just go 4 times 3 times 2 times 1. And so that works out to be 24, okay? Remember, there's a button that you can do this on your calculator with, in case you don't want to do all of the multiplication the long way. But if you don't have that kind of calculator, or you don't know how to use that button, then you can just go 6 times 5 times 4 times 3 times 2 times 1. And if you do that, you will get 720. So that's the simplest. That's just plain old factorial, okay? Then when you start doing math with it, that actually makes things a little bit easier, because 5 factorial divided by 3 factorial, you go 5 times 4 times 3 times 2 times 1 on the top, and then divided by 3 times 2 times 1 on the bottom. So the 3's cancel, the 2's cancel, and the 1's cancel, and then you get 20.
But if you times these, divided them times
Yep, so you would get the same answer if you went 5 times 4 times 3 times 2 times 1, which is, what is that, 120? And then divided by 6, you would still get 20 as the answer. Okay, the canceling just seems like an easier way to do it. But what do I know? I don't know nothing. You know nothing. All right, so for this one, 6, 5, 4, 3, 2, 1, divided by 4, 3, 2, 1. Good. And then 2 times 1. So if you're going to do this on the calculator, you have to be a little bit careful, because the 4 factorial and the 2 factorial would have to be in parentheses if you're doing it on your calculator. But again, there's not really any reason that you need to do that. The 4, 3, 2, and 1 cancel, and then 2 goes into 6 3 times, and so your final answer there is going to be 15. Okay? Huh?
The answer's 30. Oh, no, it's not 15.
Did I screw that up?
No, you're right.
Why is there what? Why is there a 5 on the bottom? There's not. It's a 3 that got canceled. Hi, Kindle. Yeah, it's 15. Is that what you got? Okay, good. Okay, then the reason why we learned that is because then we talked a little bit about combinations and permutations. And what is the difference between a combination and a permutation?
The order does not matter in a combination.
The order does not matter in a combination, but it does in a permutation. So remember, you don't actually have combination lockers, you have permutation lockers, okay? So then this is probably where you want to go to a calculator, but if you don't have a calculator, you can still do this. So 7C3, that formula is 7 factorial. So it's this number right here, factorial, divided by, anybody remember? 3 factorial times 4 factorial, because 7 minus 3 is 4. Okay? So again, if I do that out longhand, it's not that bad. 7 times 6 times 5 times 4 times 3 times 2 times 1, divided by 3 times 2 times 1 times 4 times 3 times 2 times 1. Lots of the, yep, you get the 4 from the 7 minus 3. Lots of canceling there. And then this works out to be 35. What are you confused by? Did anyone do this on the calculator and get the same answer?
Yeah.
You got what? 35?
So,
Where did I get the what? Oh, this number right here, the 3, is the same number as that one. And this number right here is these two numbers subtracted. Okay?
And then 6 would just be the same thing, but just different numbers.
Same
So
thing,
let's not do 6.
different numbers, okay? So this one right here,
Can you show us how to do a calculator for this one?
I would start with 9 factorial, so 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, divided by, yes, 8 factorial, so 8, 7, 6, 5, 4, okay? And then times what, technically?
1.
1, because 9 minus 8 is 1, so I'm going to have another 1 right there. So 8, 7, 6, 5, 4, 3, 2, 1 cancels. 8, 7, 6, 5, 4, 3, 2, 1 cancels. So then you just have 9.
Okay, do the permutation.
Okay? All right, the permutation one is almost the same, but it's a little bit easier. The permutation formula is just this number right here, factorial, so 5 factorial, divided by, you just subtract these two things, 3 factorial. So 5, 4, 3, 2, 1, divided by 3, 2, 1. Can you see without me writing it all out that the 3, 2, 1s are going to cancel? And you'll be left with 5 times 4, which is 20. Okay? Same thing with this one right here. If I go 11 factorial divided by 2 factorial, oh, that's going to be a little bit tricky. I don't want to do that in my head. So yes, I will show you how to do these on the calculator. Because only the 2 and the 1 at the end are going to cancel. So it's going to be 11 times 10 times 9 times 8 times 7, 9, blah, blah, blah. So 2 different ways that you can do this. If I want to do it just from the very beginning, 11p9, I type 11 and then hit the math button, go over to the probability menu, and number 2 gives me the permutation ones.
What one gives you for...
So 11p9 is that very large number. That's why I didn't want to do that without a calculator.
Okay.
So what is that? 19,958,000? So that's how you can do that on the calculator. Okay. There's also a factorial button that would give us the same answer if I go 11 and then hit the math button and go over to probability and choose number 4. 11 factorial divided by 2 factorial will give me the same answer. Okay?
Okay.
Okay?
Now let's get to the heart.
All right. Oh, more. Okay. All calculator stuff?
11 and 12.
Okay. 11 and 12?
No, just don't put those on
It's
the
just the
quiz.
same thing as we did before, but
It's-
you multiply by 2 first and then
Yep.
subtract.
Yeah,
Yeah.
well, let's not do
So we can really, Hannah, just do this all on a calculator. If I go to parentheses,
Just work on
5C4, so 5 math, number 3, yeah.
You can literally type in the whole problem.
Yep, you can literally type in the whole problem. And then minus 3C2, minus 3 math,
Yeah, what is the point of that?
I don't know. Hopefully you're understanding the formula a little bit also. So I just typed in the problem just the way it was, and I get 7. Am I teaching how to cheat? I'm not. I'm teaching how to use your resources. Isn't that what
next
Mr.
page.
Weber says? Okay, so same thing with this one, but we would use permutations instead. Okay? Okay, yeah, so then the fun stuff is when you actually have to think about how to use that. Okay?
You just have to
All right, so first thing is to understand the difference between a combination and a permutation. A combination is what again?
Doesn't matter.
When the order doesn't matter, and a permutation is when the order does. So, number 13. How many ways are there to select 5 actors from a troupe of 9 to improvise a scene? And since it doesn't say that the first person is going to be the king and the second person is going to be the queen and so forth, the order doesn't matter, so this is an example of a combination. We're just trying to grab a group of 5 actors from that. And then we have to solve it. So how would I solve that?
do the C thing.
Yeah, and what are the numbers that I would use? 9C5. Okay. Yes, you may not do 5C9. You have to do the bigger number first. Okay.
Always bigger number.
Always a bigger number first. What'd you get, Jordan? 126. So there's 126 different ways that that could happen. Okay, number 14. How many different 3-student study groups can be formed from a class of 15? Again, a combination because it's not distinguishing between the roles that those kids get. And then that would be good. 15C3. And what does that come out to be? 455. And then finally, we're hoping that this is going to be a permutation. Your teacher is looking for a new apartment. There are 5 apartments available. And how many ways can your teacher inspect the apartments? I guess the order matters because you're driving or something like that. So you, I don't know, I'm going to go permutation just because we haven't done one of those yet. But that's a weird one. And then how do I figure that out? 5P. How many apartments am I looking at? How many apartments am I looking at? All 5 of them. So it's 5P5. 120. So there's 120 ways I can drive around town and look at those different apartments. Okay? How do permutations work? This tells me the number.
Over
I was
0.
asking Mr. Aldrich, not Joseph Howley.
Thank you. Josie, hush. This tells you what number you start with. This tells you how many spaces to fill. So the first number is a 5 because there's 5 different apartments that I can look at. And then after I've already looked at 1, there are 4 of them left, right? And then after that, there's only 3 left, and then 2 left, and then 1 left. Okay? So that's how permutation basically works.
All right, so basically it's just a glorified way of saying 5.
Kind of. The only thing is that this one was 5P5, Colin, so we went all the way to the end. If this had been 5P3, then I would have, well, if it would have been 5P2, I would have stopped after the second number. Because I would only want to look at 2 apartments, so I could choose 5 for the first one and then 4 for the second. Okay? Joseph?
So, Nate and I were thinking,
Always a bad start.
yeah, I know. So you know how you do the divide way, where it's 5 factorial?
Yeah, uh-huh.
Okay, so you did the subtraction, right? And
Right.
0 factorial.
Right.
You can't divide it by 0.
Right. What is 0 factorial, though?
0.
Is it?
Yeah.
You don't think so? So you raised your hand and brought this up without checking on your own calculator that you have right in front of you. Strangely enough, 0 factorial is actually 1.
Why?
Okay? I don't really know.
Crazy.
I don't really know. Yeah. Maybe it just had to be that to make this formula work.
Maybe it's just confusing the explanation went to 1.
Maybe it
It
is.
does still be 0.
Still be 0. Okay. So let's rattle through these, and then fast pitch kids, you guys can leave as soon as we're done with
16. Just let us go now. We'll
16. Oh, stop it.
I'm gonna watch
Okay, what is the probability if you choose from those numbers of getting a 7?
I don't know. You times.
You're, nope. How many 7s are in there? 1 out of how many numbers total? 10. Okay. So you have a 1 out of 10 chance of randomly choosing the number 7 from that group. Because there's only one way to choose the number 7, and there's 10 numbers in there altogether. Okay, so, right, a 5 or a 13. There's a 2 of those out of 10 total. So that would be 1/5, okay? How about greater than 10?
4 out of 10.
4 out of 10, right? Because 11, 12, 13, 14, those are all greater than 10. Okay? 4 out of 10, which is 2 out of 5. Okay? How about a multiple of 30?
2.
A multiple of 30.
3
A
out of 10.
multiple of 30. So like 30 or 60 or 90 or 120. Right, none. There are no multiples of 30 in there. Okay? So that's 0 out of 10 or just plain old 0. Okay. Josie, if you get this, then you can go. Don't help her, please. What's the probability of less than 7 or greater than 10?
6 out of 10.
6 out of 10. Have fun. Good luck today. Just her. You guys have to get one right to leave. Hannah, what's the probability of greater than 6 and less than 12?
Okay. Wait, do I just
Greater than 6 and less than 12.
I know, so that would be less than 12 would be 7, right?
What's your answer?
I
No, pass. Morgan, greater than 6 and less than 12.
Wait, so do you have to add them together? That's what
Pass. Samantha, greater than 6 and less than 12. I know, well.
5?
Out of? Okay, Samantha, you can go.
It's 1/2. So we got it right.
Okay, Hannah, try again. Samantha, you're out. Probability of getting an integer. No? Morgan? Yeah. What's an integer? It's like a whole number. All of them. Go. But I asked her first. Okay, too bad you didn't get an earlier one because now it's really tricky. What's the probability of getting a number less than 10 given that the numbers you're choosing from are less than 13 to start with? Okay, so what that means is, remember what we talked about yesterday, this right here sort of tells you what your sample space is. So we're only worried about the numbers that are less than 13. So I'm going to throw out this one and throw out this one. Okay, so now what is the probability of getting a number less than 10 from these? No, what'd you say? 5/8, yes. 1, 2, 3, 4, 5 out of the 8 that are left. Okay. Okay, Morgan, you can do this. Okay, so same thing. Nope, same thing. What is the probability of getting a number greater than 8, given that we're only interested in choosing from the numbers that are less than 11? So these are out because they're not less than 11. So numbers greater than 8, given that we know already the number is going to be less than 11. Yes, 2 out of 6, which is 1/3. Okay, goodbye. Goodbye and good luck. Okay, and then the last one, probability of getting a number greater than 7, given that we're only interested in the numbers that are greater than 12. Right, that's 0. No, because the numbers that are greater than 12 are only these two right here. And none of those are greater than 7. So that means our probability of that happening is 0. Okay? Okay, we okay? Shh. We okay with that? The last one? Okay, so again, this right here tells me what's my sample space. And so what that's saying is I'm only choosing from the numbers that are greater than 12. So I'm only doing 13 and 14, okay? So now we're going to answer the question based on just those two numbers. What are my chances of choosing? Oh, why did you guys say that? Why did you guys say that? It's not 0. Oh my goodness. Right. What are the chances of getting a number greater than 7 when I choose from 13 or 14? Not infinity. No, it's 2 out of 2. It's 100%. Because both of these numbers are greater than 7, so no matter which one you choose. Yeah. So that's 2 out of 2 or 100% or 1. Okay? Thank you, Noelle, for asking about that. These guys are messing with me. Okay? Does that kind of make sense? So the second thing it says is what numbers you're choosing from. So it sort of it gives you a restriction a little bit. And then, because it did. Right, wasn't supposed to be 0, yeah. Well, Joseph and Nate are mean people. All right, next one. 2 standard dice are rolled. State whether the events are mutually exclusive, and then find the probability of A or B happening. So mutually exclusive means that they cannot happen at the same time. So can you have them add up to 12, but have both of them be odd numbers? But you can't get a 7 on a 6-sided die. Okay? So can those things happen at the same time? No. So that means that they are mutually exclusive. So now we need to figure out the probability of A or B happening. And since they are mutually exclusive, that's easy. You just have to add up the probability of each individual thing happening. So the probability of A plus the probability of B. So what's the probability of rolling a 12? 1 out of 36, because you can only get a 6 and a 6. What is the probability of rolling an odd number on, like, the sum of them? Or no, they're both odd. Is it going to be 50-50, basically? You've lied to me before. So just to make sure, I would say you can get a 1 and a 1, a 1 and a 3, a 1 and a 5, right? Okay? Or you could get a 3 and a 1, a 3 and a 3, and a 3 and a 5. Or you can get a 5 and a 1, a 5 and a 3, and a 5 and a 5. Okay? So how many? No, because they're already in there. Yeah, 5 and a 3 and a 3 and a 5 already got. Okay, good thinking though. So that's 9 out of 36. Hold on just a second. So if I add those together, I get 10 out of 36, which reduces to 5/18. Okay, the way that they're mutually exclusive, who asked that? Okay, the way that they're mutually exclusive is these are all the different things for getting both of them odd, and none of those add up to 12. So since they... You do, but then they're not odd, so that can't happen at the same time. Yeah, well, let's do another one and see an example of one that can happen at the same time. Okay, so A means they're equal. So what are all the dice rolls where both numbers are equal? 1 and a 1, 2 and a 2, 3 and a 3, 4 and a 4, 5 and a 5, 6 and a 6. Okay. And then B means their sum is a multiple of 3. Do any of these add up to a multiple of 3? Yeah. So since there's a couple in there that add up to a multiple of 3, they're not mutually exclusive. You can get... Right, it's weird. If it works, then it's not, and if it doesn't, then it is. So these are not mutually exclusive. So that means for us to figure out the probability of A or B, we have to do a little bit more work. We have to figure out the probability of A happening plus the probability of B happening, but then we have to subtract the probability of both of them happening at the same time. So what's the probability of A happening? What's the probability that you roll 2 dice and their sum is a multiple of 3? How many different ways can I do that? A 1 and a 2, a 2 and a 1. So somebody help her out because there's more. That's the only way you can get a 3, but we're looking for multiples of 3. So okay, they could also add up to be 6. So you could go 3 and 3 adds up to 6, 2 and 4, 4 and 2, 5 and 1, 1 and 5. Okay, what? Then you could also get a 6 and a 3 and a 6. That adds up to 9. You could also get a 5 and a 4 and a 5. Any other ways you can add up to 9?
6 and 6.
Okay, then the 12 is a 6 and 6. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12 different ways out of 36 total. Plus, what's the probability of their, well, I guess we did this backward, but that's okay. The probability of them being equal is 1, 2, 3, 4, 5, 6 different ways. So that's 6 out of 36. Minus, what's the probability of them being equal and being a multiple of 3? 2 out of 36, because this one right here and this one right here, they're equal and they're a multiple of 3. Okay? So 16 out of 36 total, which is 8 out of 18 or 4 out of 9. Okay? So that's a tricky one. Okay. Hopefully that will be on the test. All right. What's the difference between experimental probability and theoretical probability? Okay, good. Experimental, that's a great way to describe it. Experimental. Experimental, you actually try it out, so you actually perform experiment. And then theoretical, okay, so then theoretical, you just kind of figure it out, right? Okay? So theoretical is, in theory, if you flip a coin 20 times, you'd get heads 10 times, right? That's theoretical probability. Experimental probability is you flip the coin 20 times, count how many times you get heads. Okay, so suppose you select a number at random from the set of numbers from 90 to 99. Event A is selecting a multiple of 2, and event B is selecting a multiple of 3. So first question is, are they mutually exclusive? Can you select a number that is both even and a multiple of 3? Right. 96 is both even and a multiple of 3, so no, they are not mutually exclusive. Okay? Are they independent? Because? Independent means that the chances of getting one doesn't affect the chances of getting the other one. So are they independent if I select 2 numbers out of there in a row? Yeah, I'm assuming we're going to just put the number back or whatever, so those are independent.
Getting one doesn't affect the other.
Right. Okay, so find the probability of A and find the probability of B. Let me list out these numbers so it's a little easier for us to figure this out. Okay, so event A is selecting a multiple of 2. What's the probability of selecting a multiple of 2 from those? 5 out of 10 numbers, or 1/2. What's the probability of getting a multiple of 3? 4 out of 10, or 2/5. Okay? All right, C, what is the probability of A and B? So since these are independent events, how do I figure out the probability of A and B?
How did you when I was just going to get 4 numbers?
Well, because these dot means fill in the rest of them. They're just too lazy to list them all out. How do you figure out the probability of A and B if they're independent? You multiply them together. So I would go 1/2 times 2/5, and the 2's cancel, and that gives me 1/5. Okay? And hopefully that makes sense to you, because if we figured it out directly, there are 2 numbers in here out of the 10 that are both even and multiples of 3. So that would give me 2 out of 10, which would reduce to 1/5. So those match up. Okay? Okay, D, how do I find the probability of A or B? How do you find the probability of A or B? I've lost some of you. I'm just trying to, remind you, quiz tomorrow. Woohoo, pay attention. Affects your grade big time. Okay, I add together probability of A plus the probability of B. And then what do I have to do from there? Then I subtract the probability of A and B. Well, we already figured out all of these things. Okay? So I'm going to write them in their unreduced form, because I'm going to need a common denominator. So the probability of A is 5/10. The probability of B is 4/10. And the probability of A and B, we just figured out, would have been 2/10. So that altogether comes out to be 7 out of 10. And again, this should make sense if we just look at the numbers directly. How many of these numbers are even or multiples of 3? 1, 2, 3, 4, 5, 6, 7. So there's 7 out of 10 that match that, okay?
So we could just figure that out by
You could just figure it out directly, yeah, if you wanted to. Okay, then it says find the probability of A given B. So remember, the second thing tells you what your sample size is. So event B says multiples of 3. So I'm only interested in the numbers that are multiples of 3. What are the chances of me getting numbers out of that that are even, multiples of 2? No, because there's only 4 numbers that are multiples of 3. So it's 2 out of all 4. 2 out of 4, or 1/2. What's the probability of B given A? So now we're only looking at the numbers that are even. So out of the 5 even numbers that we have, how many of those are multiples of 3? 2. So it's going to be 2/5. All right? So that's pretty tricky stuff. There's a lot of things going on in that problem. I don't really know, but hopefully you understood that. If you didn't, you can always rewatch the video. Relive the dream. Okay, I would not like to do that one, and I would not like to do that one, okay? All right, so that wraps it up. So hopefully you'll be ready for a quiz tomorrow. If you're not, feel free to come in and ask for help before we do it.